So now we are seeing the second method of deflection, that is conjugate beam method. So let's see first the theorem first, and then we'll see what is actually a conjugate beam. The theorem 1 of conjugate beam says that the slope at a point in a given beam is equal to the shear force at the same point in the conjugate beam. So for example, if you have any beam like this, you have to first, this is your main beam, you have to make its conjugate beam. We'll see what is the meaning of conjugate beam. So actually in this case the conjugate beam will be a simply supported beam only. So he's saying, the first theorem says that if you want the slope at a given beam, suppose this is the deflection, I need this slope theta A. So the slope of the main beam will be the reaction on the conjugate beam. So you have to find the reaction over here. Now this main beam and the conjugate beam will be such that if it has some loading, the loading diagram, suppose it has a loading diagram of a concentrated load, you will first make its BMD, and that BMD, in case of conjugate beam, that BMD will become its loading diagram. And then this is your conjugate beam. The slope on the main beam will be equal to the reaction on the conjugate beam. That is the theorem number 1. Theorem number 2 of conjugate beam theory says that deflection at a point in a given beam is equal to the moment at that point in the conjugate beam. So if you want the deflection somewhere here, you have to, if this you want delta, you have to calculate the moment at this location. That is the second theorem. So these are the two basic theorems that will be utilized, just like in MAT 1 and 2, it has conjugate beam theorem 1 and 2. Now to have a clear picture of what actually a conjugate beam is, you will see here, there is two beams, a real beam and a conjugate beam. A determinant beam will always be a determinate conjugate beam. Okay, second point. An indeterminate beam will be unstable in case of conjugate beam. Why? Because the fixed end in case of main beam becomes a free end in case of conjugate beam. So since this is an indeterminate beam of ds is equal to 1, this becomes an unstable. You see, there is only one reaction over here and one reaction like this. So that is an unstable beam. If an unstable main beam will become an indeterminate beam in case of conjugate beam, right? Because here a free end becomes a fixed end. Now the question arises, why? Why we have made a free end as fixed end and a fixed end as free end and a simply supported end as a simply supported end? So what happens in case of fixed end? Here, if you calculate at this point A, your theta will be 0. As per conjugate beam theorem 1, the conjugate beam theorem 1 says the slope at a point in a given beam is the shear force at that point, the conjugate beam. So if this is your slope, that is equal to 0, then at this case, in case of conjugate beam, your what should be 0? Shear force should be 0. And if your deflection is 0, what should be in case of conjugate beam? Your moment should be 0. So see, a free end will neither have shear force nor moment, right? So that is why this fixed is given as free end. Same as the case with hinged. A hinge, here there will be some slope, right? So there will be some theta here. So theta exists in case of hinged case. Whereas if a hinge has to remain hinged, the shear force in the conjugate beam should not be 0, right? A reaction will always have a shear force? Yes. In case of hinged beam, the main beam, the deflection will be 0. Obviously the support won't deflect. The support won't deflect. Therefore the hinged case, the moment should be 0. So a hinged beam, a hinged end of a beam will always have a moment 0. So that's only because of those two theorems we are able to write it. Now this is important. An internal hinge. This is actually an internal hinge here. This is an internal hinge. What is an internal hinge? We have seen in the previous classes. An internal hinge is such that it do not transfer the moment but transfer the shear force. So in this case, the theta will not be 0 and delta also will not be 0. Why? Because a hinge case is like this. How it will deflect? It will deflect like this. Right? So it will have delta as well as it will have theta. Right? So both exist in case of internal hinge. So what an internal hinge should be in the main beam? In case of main beam, it should be a roller. Why? Because a roller will not have shear force 0 and also moment also will not be 0. So both exist in case of an internal roller. Why? Because you see the diagram, if you see any simply supported internal, if it is internal roller is there, how its deflection diagram would be like this. So this will have some slope here, here and here. So you see there is moment also here, and also there will be shear force. So that's why an internal hinge becomes a roller. So this is the introduction to the conjugate beam. In the next lecture we will see some problems on conjugate beam.